Hey everyone! So in this video I'd like to say a few more things about slope. And so we said that if we wanted to find the rate of change between two varying quantities, well, what we really should do is find the change in one quantity and divide that by the change in the other quantity. And so if we have two varying quantities, x and y, well, we're going to find the rate of change by computing the change in our output variable and divide that by the change in our input variable. And we wrote that out as delta y divided by delta x, it's shorthand. And here, this is something we called slope in the context of lines and linear equations. And so here, let's talk more about this concept of slope. And so maybe just as a quick refresher, we can find the slopes of the two lines below. And so I definitely encourage you to pause the video and at least try out the first example, see if you could find the slope of the line on the left. And so we said that the slope is just the change in the y values divided by the change in the x values of two different points. So here I'm just going to find 2 points on our line. Maybe I'll choose this one out here at the point -3, 3, and I'll choose this point out here at the point 3, 1. So we want to find the change in y between these 2 points and divide that by the change in x between these 2 points. And so I'm going to imagine that I'm starting at this point on the left and I'm ending up at this point. Right, so what's the change in the y values? What's this difference here? Well, here the change in y, if I'm going from my first point on the left to my second point on the right, now this change in y is 4. Right, it's increasing by 4 units to go from -3 as a y value to +1. And then what's the change in x in between these 2 points? Well, here we can see that I'm starting at an x value of -3 and I'm ending up at an x value of +3. Well, we can see by each of these little steps, the sides on these boxes in the grid, that there's an increase of 6 units in the x value. So delta x is equal to 6. And so our slope, right, this is the change in y divided by the change in x. Well, this is equal to, we've said above, 4/6. And this is a fraction. I should use blue there if I want to be consistent. So this is a fraction, and we can reduce fractions. And we can see this as 2/3. And so something I'd like to mention is that you might have chosen 2 different points than the 2 points I chose, and that's okay. Right, so here maybe I'll erase some of what we have here. So here, what are some other points that we could have chosen that are very explicit on this grid? Maybe you would have chosen this point here, 0, -1. Maybe you did choose one of the points I chose. Maybe you chose this point out here, 3, 1. Well, we can also see that this slope between these 2 points would be, well, there'd be a delta y of 2 and a delta x, a change in x of 3. And so we get the change in y is 2 divided by the change in x is 3. We'd end up with this same slope. And so this is just one key point that I'd like to bring up with these lines that we're finding the rate of change between 2 points, or the slope of. So the slope of a line is constant. And so here what this means is constant. This word is just saying that it's not changing. It doesn't matter what 2 points we pick on our line, we're going to get the same slope every time. If it's a straight line, that's what we mean when we say line in mathematics, is we're referring to a straight line. So the slope of a line is constant. Any 2 points we use will get the same slope. Okay, so let's go ahead and compute the slope of this other example now. Okay, so here we've got this line on the right, and again, it doesn't matter which 2 points we pick, we'll get the same slope every time. And so you might pick 2 points differently than me, but that's okay. So here I'm going to pick this point here, 0, 1, and I'll pick maybe this point down here, just to use a maybe different example than you might have chosen, and then we'll see that we get the same value. -2, -5. So what's the change in y between these 2 points? Well, that change is, I really should imagine that I'm going from one point to another. And so I'm going to go from left to right here. So the change in y is, well, that's 6, right? I'm going up 5 units, I'll end up at the horizontal axis, and then I need to go up 1 more to have a y value of 1. And then my change in x, to go from an x value of -2 to an x value of 0, well, this would be a change in x of 2. And so here, the slope of this line is, well, it'd be 6 over 2, which again we can reduce. This reduces as 3 over 1, which we can just write as 3. And so here we see the slope of this line is the value 3. And we can think of that as well, a change in y of 3 for every change in x of 1. Every time I increase my x value by 1, my y value increases by 3, so that I end up staying on the same line. I find another point on my line. It's really what this slope is telling us. So hopefully you got the same value for the slope of this line. And in this example, I kind of imagine finding this rate of change, or the slope of this line, going from the bottom left point to the top right point. And the slope of the line should be constant no matter what values we choose. And actually, it shouldn't matter what order we sort of go between these 2 points. So here, actually, I could have started, imagine starting from my top right point, and think of traveling to my bottom left point, and I should end up with the same slope actually. Right, so if I sort of start at this top right point and I want to find the change in y, I would have to go down 6 units, right? So this is delta y is equal to -6. And this feels a little scary, right? I see this change in y of -6. This feels like I might get something different than I did before. We didn't get negative values last time for the change in y. But if we see, what would the change in x be for this example? Well, I would still have to go left 2 units. So delta x would be -2, right? To go from an x value of 0 to an x value of -2, I would need to move left 2 units. My change in x would be -2. And so here we would get, it would be a slightly different looking computation at first, but this would be -6 over -2. And this would give us, well, a negative number divided by a negative number would be a positive number. So this is really the same as +6 over +2, which gives us that same 3 that we end up with. Right? So although we started with a different point, or we rearranged the order in which we computed the slope, we got the same result. So hopefully that made sense, and if not, let me just reiterate the main point that I want to make here is that we have 2 different points here we're using to compute the slope. And what I'm trying to say is that it doesn't matter what order you use for computing the slope with these 2 points. So you can sort of start at the leftmost one and imagine traveling to the rightmost one, or you can start at the rightmost one and imagine traveling to the leftmost one. You should get the same slope either way. So another thing I'd like to point out with this example here, or these 2 examples here, is that we found the slopes of these 2 lines. We found that the slope of the line on the left is 2 over 3, and the slope of the line on the right is 3. And so, what do these slopes say about these 2 lines? Well, the slope measures the steepness of the line. It measures the rate of change of the y value when we change the x value. And so a larger slope means the y value is changing more for every time we change the x value, every time we increase the x value by 1. And so here, this line with a slope of 2/3 on the left, because 2/3 is smaller than 3, it's telling us that this line on the left is less steep, or a little bit flatter, than the line on the right with a larger slope of positive 3. So slope tells us the steepness of a line. So slope, it is rate of change, but it also tells us slope describes the steepness of a line. Right? It measures the change in y divided by the change in x. And if the slope is larger, that means its numerator is bigger, right? A bigger fraction comes from when the numerator is significantly bigger than the denominator. And so if the numerator is bigger than the denominator, that means the change in y is larger than the change in x. And so there's more vertical change for every horizontal change. So a larger slope means larger numerator, larger change in y. And larger change in y means a steeper line. So here's another 2 examples. And here I ask, how do lines with negative slopes compare to the examples we saw previously? And so here I've got 2 lines, their slope is negative, and I encourage you to pause the video and find exactly what the values are of the slopes of these lines. So here, I look at the line on the left, and again, it doesn't matter what 2 points we use to find the slope of our line. It's just good to pick very explicit points. So I'm going to pick this point. It's a very clear point to me. And it looks like there's another point down here that's very explicit. And so what's the slope of this line? What's the slope between these 2 points? Well, if I start at this point on the left, well, the change in y is down 4 units for 3 units to the right. Right? So this is delta x is equal to 3, delta y is equal to -4. And so the slope of this line here, this slope, is equal to -4, right? Change in y divided by change in x, -4 over 3. Here, let's compute the next example as well. So here, let's use 2 points on this line. I'm going to use this point here and this point here. And so we see the change in y is -1, delta y is equal to -1, and delta x is equal to +3. And so the slope here is -1 over +3. I go down 1 unit in my y values and travel 3 units right on my x values, and I'll end up with another point on my line. And so in both of these examples, we see that we get a negative slope. And so what's special about these examples compared to the previous examples? Well, in these 2 examples, the line is traveling down as we're going to the right. And so the change in y will be negative, while the change in x is positive, and so the slope will be, as a whole, a negative number. And so here, the points I want to make with these 2 examples is that, and the previous examples as well, so lines with positive slope right, they travel up as they travel to the right. They're going upwards as they move to the right. From left to right, the line is going upwards, and lines with negative slope, these lines travel downwards as we look from left to right. Actually, let me create some more space here. I'll move this line up. So lines with negative slope might look something like this, but they travel downwards from left to right. And so that matches what we see above. Okay, so if lines with positive slope are going upwards from left to right, and lines with negative slope are going downwards from left to right, what do we expect a line with a slope of 0 to look like? So what should, I'll write this down, what should a line with a slope of 0 or a 0 slope look like? Well, if positive slopes are going up as we go to the right, and negative slopes are moving down as we're looking from left to right, well then we might expect zero slopes to be somewhere in between, right? It's right between positive values and negative values, so we might expect a zero slope to be a flat line, right? It's not going up or down when we look at the line from left to right. So here, one example of a line with slope 0 is just a horizontal line. Maybe I'll just use an example where we can sort of imagine explicit points. Maybe this is the point, let's say 1, 3, and this is the point 4, 3. Maybe I'll use a slightly different example of a point. Let's call this point 5, 3. Right, so what would the change in y be for this example? Well, the change in y, it's going from a y value of 3 to a y value of 3. This would again be, this would be 0, right? There's no change in the y values. And then we divide that by the change in x. Well, between these 2 points, the change in x is going from 1 to 5. That's a change of 4 in x. If I'm starting from this left point and going to this right point. And if we have 0 in the numerator of a fraction, and we divide it by some other number, at the end of the day, that fraction is really just the same as the number 0, right? If I have $0 and I split this among 4 people evenly, how many dollars does each person have? Well, they'll have $0 still. So 0 divided by 4 is equal to 0. So this is the slope of our line on the left. And so a line with the slope of 0 is a horizontal line. A horizontal line has a slope of 0. So there's one kind of line that doesn't fit in any of the categories we described previously. It doesn't have positive slope, doesn't have negative slope, doesn't have a slope of 0. And this is an example of a vertical line. So vertical lines, these kind of don't really fit in any of the things we described before. And so here's an example of a vertical line. I'm going to draw it in blue. I'm going to outline it in blue because I don't think it really appears so well if I don't have color there. So if I take 2 points on this line, maybe I'll choose this one and I'll choose this one. And I'll sort of imagine starting at this point on the bottom and making my way towards the point on the top. I ask, okay, what's the slope? How do I compute the slope? It's the change in y. And in this case, that would be an increase of 3, right? So the change in y would be 3 divided by the change in x. This is going to give us a slope. Well, the change in x, the x value of the first point is -4. The x value of the second point is still -4. The change in x is 0. And so we have 0 in this fraction, but this time it's in the denominator, right? Not in the numerator. And you might recall that when we try and divide a number by 0, it doesn't end up giving us 0, it ends up giving us undefined. It is not a really well-defined result. So this is undefined. And so vertical lines, lines that are not moving up from left to right, they're not moving down from left to right, they're not they don't have a slope of 0. Vertical lines, they have no slope, or you might say undefined slope. So vertical lines have undefined slopes, or sometimes you might see it as no slopes. So if it has a slope of 0, it's not moving up or down from left to right, it's just a flat line. If it's got positive slope, it's moving upwards from left to right. Negative slope, it's moving downwards from left to right. And then vertical lines with no slope, it's not moving left to right at all, it's just a vertical line. So now I'd like to talk about the formula of the slope of the line that contains 2 specific points. Maybe I'll call them x1, y1, and x2, y2. Right, so for the formula for this slope of the line containing these 2 points, this is just the change in their y values. We can compute that by finding y2 minus y1. And we're going to divide that by the change in their x values, x2 take away x1. And so let's see why this is the right formula to compute this slope. So I have an example here on the right where we can see 2 explicit points, right? So here's one point and here's another. And so in this example, how would we compute the slope? Well, we would find the change in the y values, and if I kind of think of myself starting from this point on the left, well, the change in the y values would be 1, 2, 3. Right? Delta y would equal 3. And the change in the x values would be 1, 2, 3, 4, 5. If I'm going from this leftmost point to the rightmost point, this is delta x is equal to 5. Right? So the slope would be 3 over 5. But how would we compute this without having to draw the picture or have to plot out these points again? Well, this change in y, it's coming from these coordinates, right? So this point on the right, this is the point 7, 6, and this point on the left is what is this? This is 2, 3. And so what's the change in the y value? Well, it's just 6 minus 3, right? To go from 3 to 6, I'm going up 3 units, and we can see that as 6 minus 3, right? The ending y value minus the beginning y value. And then what's the change in x? Well, the change in x is 5, and it's coming from 7 minus 2, right? The ending x value minus the starting x value. And so in general, when we want to compute two slopes, we're going to need 2 points. Right? And so one of them is going to have an x value, and another one's going to have, and then it's going to have a y value. And there's going to be a second point with an x value and a y value. And to really distinguish these 2 points, we might call this point on the left the first, we might say that's the first x value, and this y value here, that's the first y value. And this point on the right, we might say, well, that's the second x value and the second y value. And so that's where this notation comes from, x1, y1, x2, y2. These are just referring to points. They're referring to 2 different points. They're really just saying the first x and y values, the second x and y values. These are the 2 points we're going to use for our slope. And we just saw that if we want to compute slope, we need to subtract away the second x value by the we need to subtract away the second y value by the first y value to see the change in the y values, and then we need to subtract away the second x value by the first x value to see the change in the x values. And so that's where this formula comes from. And that's why you might see this funny notation with all these small 1s in the corners and 2s in the corners. They're just referring to 2 different points, and they're just a way of labeling these things so we can really talk about them very explicitly in this formula. So let's use this slope formula, and maybe I'll rewrite it. So here it's y2 minus y1 divided by x2 minus x1 for these 2 points, x1, y1, and x2, y2. Right, so here, that formula on the left gives the slope of the line containing the 2 points on the right. So let's find the slope of the line that passes through each pair of points. I definitely encourage you to pause the video and try this example out, these examples out yourself. And if it's feeling a little shaky, we'll talk about it in just a moment. So here, I can think of this point on the left as my first point. I'll call this one x1 and this one y1 for those coordinates, and I'll think of this as my second point, x2 and y2. And so the slope for A, so here's A, we want to find the slope. Well, what we'll do is we'll take the difference in their y values. Maybe I won't do this in a different color. I'll use the colors for the change in x and change in y. So here for A, if we want to find the slope, we're going to find the change in the y values. We're going to take y2, the second y value, subtract away the first y value. So negative 4 minus 1. This will tell us the change in the y values. And we'll take the second x value and subtract away the first x value. So this is 2 minus. So there's this negative sign here. We want to make sure that we're including that negative sign. So this is 2 take away that negative 1. So it's not just 2 minus 1, it's 2 take away negative 1. And then here, negative 4 minus 1, well, this is negative 5. Right, if I can read this as negative 4 plus negative 1, right? Subtraction is just adding the opposite. So here I can read minus 1 as adding negative 1. And when I add these two negatives together, they become more negative, giving me negative 5. Now in the denominator, when we subtract away a negative, it's like adding the opposite, right? So adding a positive 1, and so 2 plus 1 is 3. So the slope is negative 5 over 3 for those 2 points. And we said earlier that we can change the order in which we compute the slope. We can sort of pick whichever point we want as the first point and whichever point we want as the second point. And so you might have chosen this in different order. You should still end up with the same or an equivalent slope of negative 5 over 3. The main thing you want to look out for is that slope is change in y divided by change in x. So make sure that your difference of your y values is in the numerator. Okay, so let's do another example. Here's b. We want to find the slope. It's the change in the y values divided by the change in the x values. Here, I'll just go ahead and show you, maybe if we use this second point on the right, well, if we count this as x1 and y1, and we counted this point on the left as x2, y2, this formula should give us the same slope as if we did it in reverse. So here we've got the change in the y value, so y2 minus y1, this is 5 minus 1, and x2 minus x1, that's negative 4 minus 4, and 5 minus 1 is 4, negative 4 minus 4, that's negative 8, and this comes out to be negative, I'm going to write this as just one big negative number, negative 1/2, right? 4 over 8 is 1/2. And if I take a positive number divided by a negative number, it's negative. So we got negative slope here. And so if you would have done this in the other order, you would have gotten the same answer. So you might have done that, and hopefully you got the same result, negative 1/2. And then this last example, C, this slope here is, here maybe I won't label these x1 and y1, x2 and y2. I'll just think of this second point as this x2, y2. So I've got 6 minus negative 1. That's 6 minus negative 1 over here 7 minus 7. So 6 minus negative 1, that's 6 plus 1. 7 minus 7, that's 0. This is 7 over 0, which is undefined. Right? So this last line is undefined slope, and we can see that makes sense because here they both have the same x values. These 2 points have the same x value, and so those points lie on top of one another. They would correspond to a vertical line. And vertical lines have undefined or no slope.